Hello and welcome. My name is Lumor Sunil, and in this video I'm going to show you my implementation of the quad tree in SIG and what I do to fix the issues that have arose during the implementation, such as the issue with some of the rectangles that kind of merge into other rectangles, don't really collide correctly. And the reason they do that is because they get orphaned, basically. You have, when you insert a lot of bodies into the quad tree, it can only fit so many bodies inside it, so it can only have 10 per, or whatever you have as your maximum per page. You can, let's say it's 10, you can only have 10 per page, and then it has to subdivide and put the rectangles in their bodies or in the quadrants. However, if you have rectangles that kind of span over the core or the edges of the quad tree quadrants, then you cannot store it inside one of the quadrants because the rectangle has to be fully contained within the quadrant or page that you want to insert it in. So my solution to this is that when you insert, it might end up as an orphan entry. And what I do then is I put them in a special list called orphaned entries. So I put them in this list. So I created a new list. I'm initializing it here. And when we populate the quad tree, which we do here, so we insert it, but if the insert function returns false, that means it couldn't be inserted into the tree because it didn't fit. So then we simply append this into the orphaned entries list. And what we can then do is in our intersection function, we have to check against the orphaned entries as well. So if we have anything in the orphaned entries list, then we can intersect those by just going through the list and checking for intersection for that entry. So that way, yeah, we do get a little bit of extra checks that we have to do, which we have to do for all the bodies that we check against, but it's still not that much amount that ends up in the orphaned list. As I've seen, there might be like, well, it depends on how many you can fit in each page and how large your rectangles are. Like how many entries can fit into one of the quadrants. If it overlaps a bunch, it will more likely end up as orphaned. And also, especially along, as I've noticed, along the midpoints. I'll show you when I run the program here. So I've been, I'm also checking here all the ones that are in the tree are displayed as white rectangles, and all the ones that are orphaned are displayed as red rectangles. So this one here, for example, this one is orphaned. And it used to be, before we didn't check these collisions, that they could, if you had two orphaned, like these ones, you had two orphans near each other, and you push one into the other, it would actually just go through the other rectangle. So I'm just gonna show here how it looks here, because you can see that now it works because we are checking for the orphaned ones as well, except that, yeah, it's a bit more, yeah, we have to check all the orphaned all entries in the orphaned list for everybody that needs to be checked. So it's not optimal, but at least it fixes the collision issue. And as you can see here also, it's almost only at this middle part where you can find these orphaned rectangles, and that is because they actually end up in the global boundary, like the root level. So the root level is the entire screen here, the green rectangle. And the green rectangle can only hold so many items. They can only hold 10 rectangles, or 15, or whatever I set it to. There's a limit. And because of the way it works with inserting, and the rectangle body has to be contained entirely within one of the quadrants or one of the pages, since all these that are at the midpoint of the screen, they actually have to be stored on the root level, because they kind of they are at the boundary of the root quadrants. So yeah, that's why we see them being on these lines here, and I've been pondering about a bit how to fix it, but this is like a quick and dirty fix basically for this issue, so that the collisions actually work, and it doesn't seem to take that much hit of a performance hit to actually do those extra collision checks. I mean, it's more important that we actually get correct collisions than we get like a couple of more FPSs out of it. And yeah, so that's basically all I did to fix this issue. And so yeah, that's all I wanted to show in this video. So thank you for watching, and see you next time. Bye.